Hello everyone. Thanks for watching the video. This video actually is a little elaborated re-recording of my meetup session that I presented the data collection and system design step for ML implementation project. It was pretty much only touched during the session, but here I have given a little bit more depth and detail as much as possible from the any ML implementation project context. So let's move on. Even though I would have to give you a shorter videos on different aspects of the data collection and system design, but kind of keep following the series. That way, it'll be easier for you to catch up and relate. So last time when I had a conversation, we focused purely on the step one, where we discussed about the pre-steps for the any initiating an ML project, to the big picture, what, why, how, and all those. Second step was about the collection of the data and that how the system should be designed. That approach. So basically, even before you start any kind of activity, your exploratory data analysis and sampling and all that activity, you need to have a plan and execution of collecting the data and have the data ready and handy with you. So let's start and focus and see what are the different areas where we need to run our thoughts into, and then from a step-by-step structured approach, how can we ensure that we have the right kind of data in a right possible manner available with us. So let's move on. So first thing that we need to focus is assessing your data requirements. Sometimes I've noticed in my a lot of my projects that I've worked on, people jump into collecting haphazard data wherever they can, but it's really neat. There are different aspects or the dimensions of a data collection, and let's focus on each of those areas and what to think about. So once you have organized your thoughts, your actions will align along the line, right? So first is assessing your data requirement. And how do you assess? The very first thing, in our day zero session itself, sorry, I think day one, step one session, we have discussed the problem statement definition, objective of your activity, and the roughly high level source detection. So what we did, let's take a little recap. We defined the business problem and the objective, like basically what's my ML model and expected to achieve. Is it a classification problem, a regression problem, or clustering problem? Based on that, you need to decide what kind of data you would require, right? So what would be my KPI or target variable? Basically, what would I need to predict, how I need to predict it, and what would I need as a influencing factor or a feature for that KPI to be predicted. So you have to have a list of such KPIs which you will use as part of your day. You need to have a little initial identification of the data sources, which you need to later on dig deep, get to that. But ideally, identify your sources, what kind of data is currently available. It's not only about what you require, it's also about whether you have it. You might be, because especially in organizations and organizations which are kind of not just a small startup, it's an enterprise by now and has been running into organizational changes such as spinning in, spinning off. So ideally, there are a lot of data sources that you cannot even have access to. So you need to know what data you can have currently available with you and what format they are. Is there an external source needed? For example, let's say, you cannot have or you do not have a direct access to a specific system's databases or directly into their system, file system. What probably you can have is they reach out to them and they say, okay, I will let you have access to this particular data. You will expose it through an API. You need to somehow, query that API and have your information collected. So is there anything? Is it open data sets? Like in this current example that I was talking about in the series, was about California jurisdictions house price prediction data, which is available from Kaggle, it's also available in my GitHub, right? So is it an open source data set that you can use without any concern or without having to take any approval from anybody? Yeah, that can be one approach. Another is it an kind of information that you need to scrape some kind of website, probably social media information. So you need to figure out based on your problem statement, based on the kind of outcome that you're planning to serve. You need to figure out what kind of sources needed, internal along with externals. Is synthetic data an option? Is if real data is limited? So I'll give you an example. In one of my previous companies, I'm not taking the name. So that company had a lot of security concerns in, using the data. The data was being generated somewhere in the U.S. data center, and most of the developers were sitting in India. So it was huge infrastructural challenge for the India-based developers to work on that data set that is sitting there from here, because the data was pretty much far away. The latency was killing the application performance or even the work experience on those data sets. The concern, looking at the data, I'll give it a little, story so that you can figure out where the synthetic data may come into play. So the question when the architects reached out to the operations team or the data generation data source team saying that, hey, you know what, we need this data. Can it be somewhere nearby data center? Now, considering the data center, because they said no, it's classified data, so it cannot go out of the company and not even go out of the country. So then that statement was challenged, saying, hey, every data cannot be classified. You must have certain data that is classified, percentage of the data that needs to be classified, but not everything. And whatever is classified, there must be some kind of masking or some kind of security measures that can be taken. And that data can be taken to a cloud, which is nearby to the applications, with all security measures in place. How do we ensure that you can give us that data? They said, why don't you classify and certify your data? That's when the cat came out of the bag and said, hey, you know what? Since last, probably it's 100-year-old company, we have not been classifying it. Or even if we have the system, not everybody is doing that. And it's pretty much far back in time that it's not easy to kind of go back and change that situation. So that's when this synthetic data, whether real data is limited, was utilized. It came in handy to kind of generate a synthetic information built up to ensure we can show what data is classified. I mean, what data can be taken out, what data cannot be. So synthetic data generation was utilized. It's one of the use cases. There could be many more. I can come up with a very specific use cases related to synthetic data, but you know, all in all, you can say this is what you need to also figure out while you're planning your data requirements. When you're assessing your data requirements, right? Now, with that in mind, next step is about your 4V and DQ. Let's dig into that. You are determining your data requirement from 4V dimension. Now, what is that? Volume. How much data is needed for model training and validation, right? So is it like little data, some data you need for your model training? Do you need a large data? What kind of data that you're dealing with for your training and validation? Or you can say training set and test set. Get into the details in upcoming videos. What variety, what types of data that you're needing? Images, text, audio, numerical or categorical, what kind of value that you're going to deal with is what this aspect or this dimension of the data tells you, that you need to make a decision based on your requirement and your objective. Velocity. Does the project require real-time data or batch processing? Is it an AI model that has to respond to, let's say, emergency, uh, you know, predicting an emergency situation based on some real-time data? That the velocity is a different kind of data processing, storing, all of that different method. But let's say you need this data for it for um, updating, um, let's say someone's investment decision. It doesn't have to be right away. It can be, 1 day gap or few hours gap is okay. Now, next comes to veracity. So, veracity is how accurate and reliable is the data. Because if you're working within uh, an organization or you're capturing data from real life users, as in, let's say, their behavior, their web tracking behavior, or their health tracking data, all of that, how accurately you are able to collect that information. Especially, it's a more problem in an organization where siloed different groups are generating the same data. But I wouldn't say same data. Let's say, take an example, um, order management in a company. Last 20 years, there are 5 different kind of ordering systems in 5 different teams, and they are generating. They have a different SOPs, right, and different way of collecting. Probably they have not been using the same standardized ERP system for the order management. So order data is coming in different structures, and I would say it's not giving you the some of the data values are missing, some are not rightly, rightly, I would say, standardized in terms of their appearance into the source system. So how accurate and reliable is the data? And secondly, sometimes in some cases some of the records have been deleted, so they are no more tying back to the other systems related information. So some information is deleted, some information is still sitting, and you don't know what the remaining information is to tie back to, right? For example, let's say there are some order management. There are some shipments have been deleted, but there are associated invoice somewhere sitting. You don't know how to associate that order with the invoice with the shipment. So just giving an example where you can relate when accuracy and reliability is a concern, especially if the company is growing organically. Second is your DQ, evaluate your data quality. So this basically focuses towards completeness. Are there any missing values? How they should be handled, if there are any? Consistency. I just gave an example of consistency when I was talking about the veracity, right? So there is a conflicting information across sources. You are not able to come to a single source of truth or a single truth with all ties, you know, taken care of, all ends taken care of. So consistency becomes a challenge in many organizations that I have in person experienced. So that is another area of data quality. I mean, if you have it, how are you going to deal with it? Are you going to let go of those instances, or are you going to massage those data? You need to have a plan around that right in this stage. Now, this is the stage, is a step 2. After you have understood your problem and objectives, I've discussed about that in the day 1, step 1. And before you start your EDA and sampling, your exploration and sampling you starts, and before you start, you have to have this data sorted. As in, you need to have the data collected before that, and before that, these kind of planning you need to do. Timeliness. Is the data up to date and relevant? Like, let's say you are expecting a real time data, but you have the data that is available. It's coming to you only in a half a day time. So you cannot commit downstream. The application will real time predict something, whatever it is that you're predicting, right? So you have to set your assumptions based on how soon will you get the data. For example, let's just take an example. It would tie back the consistency and timeliness issue. Let's say you have a reporting or an AI system to deliver downstream, and you have the system real time updated somewhere with certain value. And in another data system, it is coming in a batch. So if you real time connect this data with the one system's data with the other system's data, ideally what you're going to get, you're going to see the join will not happen, the data will fall out, you'll get confused. But after 6 hours, when the data, 6 hours or half a day or whenever, whatever is the timeline, the data has come to the other system. Now, when you're joining, you're finding a match. So, ideally means your timeliness is your timeliness gap, that 6 hours or 12 hours gap that you have, is actually hurting your consistency and requirement. Okay. So, these are the things you need to focus, look at the sample data, and figure out you know, what are the different, I would say, what's in your scope to handle, what is beyond your scope, what cannot be committed downstream because you don't have that data available with you. You don't have the control of all the required data in your, in your arsenal. So you have to kind of take care of these dimensions, these 4 dimensions of the data and the 4 dimensions of the data quality. Roughly, you have to keep an eye on. Or I'd rather say be aware, even if you don't know what to do with that. Now, next step would be labeling or tagging and ethical bias. Let's discuss this. Let's say you have a supervised learning tutor. Let's say you have a target variable that you need that needs to be, you're doing a, I would say, classification. Let's talk about it. Let's say you're doing a classification and you need the images, the tagged images, to be as a supervised as your reference data set with which you will be training your model. The problem is if the data availability is not there, all the data is not labeled, or very limited data is labeled, then you know that either you need to kind of do some work from your end to use take care of that gap if the data labeled data is not available. Let's say um, you can use manual annotation, which would be costly and cumbersome and time consuming. You may give it as a task and get it done through crowdsourcing, right? And also, third option, if you don't have the time and money to do any of this, then the weak supervision. So basically, you would have a little low accuracy model with a weak supervision because you couldn't give enough labeled images to your model. So probably you have a computer vision based model, which would not give you a very accurate. I mean, it may tag an eel as a snake just because you haven't been able to train your model as strongly as you should be doing, right? So that is also, if you have that gap, you must know the gap so that you can work on it. And finally, is you're focusing on the ethical bias and concerns. When I say ethical bias, what exactly I'm meaning? Does the data set fairly represent all true? Like, for example, I'll tell you. Before I talk about the, sorry, before I talk about the, um, give me one sec. Yeah. So let's take an example. Uh, for any kind of statistical sampling, for a statistical significance calculation, what you need to identify that you must have, I mean, forget about the stratified sample or random sample, that I'll come to it later on. But the question is, any kind of, irrespective of the type of sampling you're doing, you must have a good representation of all categories within your groups. So the idea is that if you are collecting data for feeding your model, let's say for a loan delinquent app, and all you collected the information, delinquency information, is about either Mexicans or Afro Americans or Indians, but you have excluded entire white groups. There may be a possibility, right, that there are white people who don't pay loan. It's possible. It's not impossible, right? We cannot go into white supremacy. So, but you have collected the data, excluded entire white race, and you just, come up with a half represented data set. You have come up with a model where it shows 100% Africans don't pay bill, 100% Indians run away, and 100% Mexicans go to jail for not paying. So basically, that primarily means you haven't done your research, you haven't done your homework. So you need to have a fair idea what kind of, like, I'll give you an example. I haven't experienced myself, but I've seen that YouTube, when long time back when YouTube was, initial days when it just started allowing people to upload photos from their phones, they suddenly started noticing a lot of upside down photographs were uploaded. And then initially they couldn't figure out the reason. Later on, they found out that while doing their user analysis, they did not have any representation from left-handed users, and that was causing it. So the fact of the matter is, you need to ensure that your data set is as complete as possible. Are there any regulatory and privacy issues? It could be GDPR, HIPAA compliance. Like, are you taking any PII data while you're collecting your data? If you are, you must have an approval in place, consents in place. Are you taking someone's healthcare data, health information, and you are, first of all, ingesting it, you're processing it, and then finally you're serving it to some other people without even, first of all, taking the consent, and secondly, not even letting the person know that is being used. So there is also certain areas, regulatory and privacy issues, that needs to be kept in mind before even requesting for any information. Is data anonymization required? I just talked about the data anonymization primarily is around when you're talking about PII data. Now you say, okay, you know what? I'm not going to take detailed information. Probably I'll take a summarization so that there is no personally identifiable information would be available. I'll just take account of it. You give me masked data. I don't need the customer ID. I don't need their phone number. I don't need their, national ID number and all that. What you need to do, mask it or encrypt it and give me an anonymized data. So that is, you need to something plan around it. Now, next step is when you're assessing your data requirement based on next step. You're trying to find out the data processing and storage infrastructure that you would require. So you need to define your data processing needs. Like, what kind of transformations would you require? So when I say normalization, encoding, feature engineering, I'll come to these later, but ideally, because remember, you're receiving your information from different sources. The sources are different, the teams are probably different, the sources probably are different system from the hardware perspective as well, right? So different systems would have their own flexibility in terms of, there may be some precision gaps when the data is coming from three different systems. They may come, the float informations would come with different precision on the decimals. Possible. There could be a scaling required, kind of to standardize the information. As I will talk about standardization and normalization, two kinds of feature scaling possible, but I'll not dig deep into that. But ideally, when you get into the transformation stage of your information, you need to know what kind of transformation you might need, and you will only get to know that once you have requested for some sample data from different sources. You need to reach out and have the sample data, and based on that, So it's an active thought. Sometimes I have noticed people reach out to different teams and then they are not able to articulate what they need. And after they got the data, they don't know what to do with it. So it's like they're in a complete state of confusion. So that's why I would say that, these kind of clarity should be there right in the beginning. Even though you're going to use these normalization encoding 2-3 steps later in the process, but you must have the clarity now itself. Do you need to balance classes for classification problems? So these are the few things that I'm not getting into the technical detail because this is not the right video for that, but you understand that this is something when you've got the data and you're treating the data, that's when you need to have all these considerations. But you need to have the visibility that you need, these kind of things are on the way. Are there outliers that needs to be handled? Yes, of course. If you have a lot of outliers, you may have a misleading, misguiding outcome. For example, let's say something is showing as, let's say there is a mean, let's say for a pizza delivery, the mean time is 30 minutes, right? It's a mean time, and it's a very consistent, delivery delivery group. So you have your standard deviation is pretty less, so you have a little bit consistent data. So from 27 minutes to 35 minutes, entire your data set has their delivery times listed. So you be and mean being 30 minutes. So you have pretty consistent, window. But then maybe someday it took 45 minutes, someday it took 2 minutes. So does it mean that you're going to take that as your minimum value? No. You need to shave off such instances, and you need to basically get rid of such instances so that you're not, you know, because then these kind of outliers will get into your data and force. It's like a bug. It will force others. If you're not looking into the data in the outlier analysis, you're not doing, you would end up thinking, oh, you know what, 2 minutes possible. So you will set the expectation everywhere, 2 minutes we can do it. Well, it was someday it happened, something happened. Probably it was a glitch, whatever. So you need to ensure you have a proper outlier treatment is there. Then you have consider your data storage. So now that you have defined your data processing needs based on the kind of problem, kind of ML model that you're going to deal with and the data sets you're going to deal with, you need to now think of the data storage and infrastructure. I'll talk about the ETL and ingestion in my next video, but ideally is where will you store it? This is a very high level. I mean, you have invited your guest. The data is coming. Everybody has agreed to give you the data. So the guests are coming. Where would you host them? Would you host them in your house? Would you host them on some venue? Would you host them in a, vendor agnostic venue where different vendors are giving their services? So ideally, it's a cloud, it's an on-prem or hybrid. Exactly what, right? Where will the data be stored? How will the data be accessed and processed? So basically, will it be, first of all, will it be pushed by the data source system? Will it be you probably, getting into their access, the database? Will you be doing a JDBC pull from your end? Will you store it into your data lake or in distributed system? Is it in your Databricks? Depending on what kind of data, what volume of data, what frequency of data you need to have, how will you access it, how will you receive it, how will you process it? Basically, how will you store it? Do you need a data pipeline automation? Sometimes data science teams would require the help from a data engineering team saying that, hey, you know what, I need the data pipeline automated. The other says, hey, you know what, I don't need anything. I'll just run a small ETL script. It could be a simple Python script or anything. Probably I'll write a PySpark. It will connect back to the other system and it'll give me what I require. So I really don't need a specific pipeline to be set up as such. But depending on the scale, depending on the requirement, you will decide whether or not you would require an automation. Would you need an ML flow which would also collect the information and store it back into the feature store? So you need to have that panoramic view at this point in time. Now, next is data update frequency and data feasibility. So what you're doing here, you're planning for continuous data updates. Will the new data be added over time? How frequently will the model retrain with the new data? So basically, if you go just by this, sorry, I keep messing up. Okay. So basically, let's say you need to train your model and you need to probably receive, maybe it's a transaction data that is training your model. And the transaction data may come in real time, may come in event driven approach. Sorry. And may come, as a frequency of overnight job running batch extraction. It could be anything, depending on the kind of business outcome you're serving, business or whatever outcome. It could be a tech outcome that you're serving. You need to find how how uh, how frequently your training data set would collect the data. Depending on that, you would have to set up the pipeline and have a suitable data store for yourself. And secondly, even if the data is coming real time, am I going to train my model real time or not? So that is the that these are the few nuances that would help you make the decision on the next step that we will discuss in the next video, which is about the blueprinting the data pipeline blueprint and execution. So you also need to see the data feasibility. So data feasibility as in, can the existing data support the ML model's objective? For example, you're trying to predict something that you never have an access to the data. So it's also a moment of truth when you can say, hey, you know what, you want this feature, but unless there are these steps taken, I cannot provide that feature because probably it requires someone's PII data to be able to predict that. And I don't have access to that PII, or I'm not supposed to, you know, it's not legal for me to get that data. So data feasibility is one other thing that you need to pay attention to. If data is insufficient, what are the next steps? So basically, are you going to collect more data? Are you going to generate or synthetic, this last time I discussed the synthetic data generation. That is also an approach. What are the approaches? Is it something that you have to say no to? Because, you know, nothing can happen, so you have to no can do, so you cannot deliver that feature. And then, okay, so I think I would go back to this one. So roughly, this is what, I wouldn't say this is concluding, but the initial steps where you need to keep in mind what all the things that you need to keep an eye on. This is your first dimension of the data collection and system design. So thank you for watching. In the next video, I'll come up with the next step of the same step, next sub-step of the next step, primarily as the other dimension, which I just showed you. This one, data collection and processing blueprint. We'll talk about it in the next video. So that's it. Thank you very much. I think I'll